Welcome back to the second session of the topic. We have just explored estimates and we have looked at why you do it and how you should go about doing it. So now we're going to move on to accuracy and precision in measurement. A quick dictionary definition. Precision has to do with the degree of refinement with which an operation is performed or a measurement is stated. How fine-tuned is the measurement stated or the operation is performed? The degree of refinement of such is what we refer to as precision. Accuracy, on the other hand, has to do with conformity to the truth or freedom from mistake or error. So if something is truthful, then it is free of error. If it represents true value, if a measurement represents the true value, the real value, then we can look at it as being accurate. The two are not different, they are not the same, they are very, very different, but they are related to the sampling error in your work, in your field work, or in your data collection. Okay, so if you use unrepresentative sample, then you are going to have a lot of sampling error. Also, if you introduce bias, instead of going to make sure that you cover enough places across the study area, you decided that, oh, let me just do this part, it's easier for me, and let me just talk to these people, they seems easier to talk to than those people. Then you have introduced prejudice into your work, and once you have this kind of bias in your work, you are going to have problem with the precision and the accuracy, because whenever we do measurement in a scientific endeavor, we want to make sure that we can achieve the level of precision and accuracy that can help us to make an unbiased and accurate judgment about what we have just observed. So when you look at precision, how do we put it when we think of scientific research? Your work will be precise if similar results were obtained when the measurement was repeated over and over again. It might not necessarily be exactly the same, but the difference is not so distinct. So if I take a measurement of let's say your height, if somebody else comes and measure your height, maybe in few months time, or using the same procedure you use, assuming that you are not growing any taller anymore, your height should still be within that same range. Okay, if somebody measures the air quality at the same time you measure your own air quality, but on another, there may be another year, but the same season around the same time, we will expect that, give or take, the fluctuation should not be so high that you are seeing 10, 20, 30 degrees different. Then something is wrong. So precision can also be captured by using the standard error of measurement. So you can compute the standard error of measurement with some statistical procedures. So you can use that to calculate how precise your measurement is. If you take care of precision and you try as much as possible to increase your precision, then you are doing so well in reducing random or sampling error. Okay, so if you look at accuracy in measurement, we are saying that if you have an accurate measurement, you have a value that represents the true value of what you have measured. What you have measured is very, very close, or exactly what it is supposed to be. If I measure the perception of older generations in terms of change policy in academic environment, depending on the situation, we will expect that if I do it over and over and somebody else comes to repeat it for the same generation of people, we will expect that for my result to be, for my measurement to be precise, if somebody uses that same instrument that I used, they should get similar result. But in my situation, it is impossible to have the true value, because it is not possible to know exactly what is the true representation, what is the real value of the perception of the people. What we can only try as much as possible is to be precise. But when we talk about physical sciences, it is possible to achieve accuracy depending on the instrument that you use. So whenever we talk about accuracy, we should think of how close is our measurement to the truth, or how close is our estimate to the true value. Okay, that is a quick overview of what we mean by precision and accuracy in measurement for scientific research. Let's take a look at some examples. A measurement that is faulty could actually be precise, but not accurate. Okay, so when we do research, we must make sure that we try as much as possible to ensure accuracy and precision. If we look at this dartboard, okay, the target, the real population value, the real value that represent the population. Remember, whenever we do our surveys, we are using the sample population to represent the real population. So whatever we measure for the sample, we are making the assumption that if the sample is representative of the population, whatever we measure for that small sample, a representative sample, it should give us an idea of the real value for the entire population. If I measure the body temperature of 20 people in the class, if there are 50 people in that class, if I take them, the samples that I took, which is, make sure I took samples that are representative, the temperature of those people in the class should be close to the average temperature of everybody in the class. So the average temperature of everybody in the class is the real value that we're looking for, which is the population value. But if we look at the sample, since we don't want to take the temperature of everybody because it's too tedious, so we take a sample. So when we do our survey, that is exactly what we're trying to do. It's impossible to cover the entire population, so we take a sample to represent the entire population. So in this situation now, let's assume that those stars, the 3 stars you can see, are our survey value. And the real value is right in the middle there. That's what we call the bull's eye. So the bull's eye is where the real population value is, and the location where you have the stars are where our estimate from the survey points to. So in this situation now, if we ask the question, what's wrong with this survey? This survey is imprecise, because now we have it, after repeating the survey 3 times, it's not coming up with the same or similar values. The values are still quite different from one another, and it is also not close to the real population value. So our estimate in this situation is not precise, because when we repeat it, we are not getting the same value or similar values. And also when we look at each one of them, one is very close, but all the other ones are very far away. So this is quite close, while these and these are much further away from the real value, which is the truth that we are looking for. So in this situation, this is imprecise and inaccurate measurement. Now let's take a look at another one. You have 3 surveys. The 3 of them are quite close together, So in this situation, we have a precise measurement, which means the instrument and the sampling was done quite well. So our results are quite close. Which means repetition of the survey yielded similar values. However, we are still very far away from the truth. So in this case, we will say we have a precise estimate or measurement, but we have an inaccurate estimate or measurement because it is far away from the truth. So, what do we need to do? If we use large samples, we can end up with this kind of situation, okay, whereby we have lower sampling error, which reduces which increases our precision. But however, if we go on and sample very similar people that are not very representative of the entire population, then we end up with a biased sample which reduces our accuracy significantly. So in this situation, we have a large sample which is large enough to reduce our sampling error, so we ended up with a precise measurement. But because we sample biased, our sampling is biased, we ended up with a very inaccurate estimate